Okay, hello everyone. Welcome to my presentation on fundamentals of neural networks. Today we are going to explore some exciting concepts that form the backbone of modern artificial intelligence. Let's dive in. Now, introduction to neural networks. Let's start with the basics. What are neural networks? In simple terms, neural networks are algorithms modeled after the human brain. They are designed to recognize patterns and make decisions based on data. Just like our brains consist of neurons, a neural network is made up of nodes. Each node take input, process it, and then sends the output to the next layer of the nodes. Now, why are these networks so important? Well, they are behind some of the most advanced AI technologies we use today, from facial recognition to language translation. Neural networks are essentially the thinking part of AI, helping machines make sense of the world. The basic structure of neural networks has three main components: input layer, hidden layers, and output layer. Input layer will receive data, hidden layers will process it, and the output layer will give us the final result. As we move through this presentation, we'll take a closer look on how each of these components work. Now, types of neural networks. Let's talk about some specific types of neural networks. The first is convolutional neural network, or CNN. CNNs are especially good at processing image and video data. They are used something called convolutional layers to capture special patterns and making them perfect for tasks like object detection and facial detection. Next, we have recurrent neural networks, or RNNs. These are designed to handle sequential data, things like time series data or natural language. Which make RNNs unique is that they have memory. They remember previous inputs, making them ideal for tasks like language translation or stock market prediction. Finally, we have generative adversarial networks, or GAN. GAN consists of two networks, a generator and a discriminator, that work together to create realistic data. They are often used for generating art, images, or even synthetic video content. Now, basics of training neural networks. So, how do we train a neural network? Training is the process where the network learns from data. It starts with a set of weights, basically numbers, that determine how the input is transformed. These weights are adjusted through a process called backpropagation, where the network learns by comparing its predictions to the actual answers and gradually improves its accuracy. Optimizing algorithms like gradient descent or ADAM are used to minimize errors during training. These algorithms help adjust the weights to reduce the gap between the predicted and actual results. As we refine these weights, the model becomes more accurate and better at making predictions. Now, activation functions and loss functions. Let's talk about activation function. Activation functions introduce non-linearity to the network, which is critical for learning complex patterns. Some of the most common activation functions are ReLU, rectified linear unit, which is often used in hidden layers; sigmoid, commonly used for binary classification; and softmax, which is a great for multi-class classification task. Now, on the other hand, loss functions measure how far off the network's prediction are from the actual results. For example, mean squared error, it is often used in regression tasks, while cross entropy loss is used in classification. Minimizing the loss function will help us improve the model's accuracy. Now, overfitting, underfitting, and regularization. One of the biggest challenge in training neural networks is balancing between overfitting and underfitting. Overfitting happens when models learns the training data too well, including noise and outliers, making it perform poorly on new data. On the flip side, underfitting occurs when the model is too simple and doesn't capture the underlying patterns in the data. Now, to address these issues, we use regularization techniques. One popular method is L1/L2 regularization, which adds a penalty to the model's complexity, preventing it from becoming too fitted to the training data. Another method is dropout, where we randomly drop neurons during training to make the network more robust. Early stopping is also used to halt training when the model's performance on validation data starts to degrade, preventing overfitting. Now, deep learning frameworks. When it comes to building neural networks, we rely on deep learning frameworks to simplify the process. TensorFlow is a powerful open source platform that is highly scalable, making it great for large projects. PyTorch, on the other hand, is known for being user friendly and is widely used in research. It offers a dynamic computation graph, allowing for flexibility when building models. And Keras is a high level API that simplifies the model building process and works on top of TensorFlow. It's especially great for beginners who want to quickly prototype and train models without getting into complexities of the underlying algorithms. Each of these frameworks has its strength, and the choices between them depends on the size and type of your project. Now, to wrap up, here are the key takeaways from this. Neural networks are inspired by human brain and are essential for recognizing patterns in data. Next, there are different types of neural networks, each suited to specific tasks, from images to sequential data. Then, understanding the basic of training, activation functions, regularization will help us improve the performance of our model. And TensorFlow, PyTorch, and Keras are popular frameworks that make building neural networks more accessible. Okay, thank you for your attention.